All right, today is 3.4, the distance formula. Hopefully you weren't too scared by all of the problems that I have listed. It really looks like a lot, but I promise you it's not going to be too bad. We're going to skip the first one. It's pretty easy if you wanted to give it a try on your own. I just thought it was too easy, so I skipped it. Okay, we're going to start with number 2. We're going to plot the points 4, 5, and -3, 5. So plot those on our graph. We'll draw a line segment to connect them, and then find the distance between the points. The distance in units is the length of the line segment that connects those 2 points. So if I count all of those little boxes in between, they are 7 units apart. So their distance is 7 units. Hopefully that's nothing difficult. Next one, again, I did backwards. I accidentally gave the answer first. But plot our points, 6, -3, and 6, 8. Draw a line segment to connect them. This is a vertical line versus a horizontal line, but the process is still the same. We're going to find the distance between those points, give the distance in units. So if I count all the little boxes in between them, that's 11 units in between those 2 different points. So give the distance in units, it's just 11 units. All right, and then moving on, we have a couple of different examples here. Notice that when we have horizontal and vertical lines are very easy to count because we can just count the boxes. When we have diagonal lines or lines that are going through the grid lines on the graph, it gets a little bit harder. But I can always create a right triangle between the 2 points. Okay, so we've got our 2 points graphed. I connected them with this horizontal line. No, not horizontal, diagonal line. And then I made it into a right triangle. And then I counted the distance. Okay, so it's 3 units long and 4 units tall. I can then use the Pythagorean theorem, because it is a right triangle, to find the hypotenuse, which, after I do all the math, would be a distance of 5. I can also rewrite the distance the Pythagorean theorem can be rewritten into the distance formula. The distance formula is just the x's, we can pretend are our a squared, plus the y values, if we pretend that's our b squared, and then equals c squared. Well, if I take the square root of both sides to get rid of the c squared, that's where that comes in. So distance formula and Pythagorean theorem are actually the same exact thing, just rewritten a little bit differently. Here's an example on how it works. The only thing to make note of is to be careful with the negative numbers. Squaring a negative number will result in a positive number, because like -5 squared, -5 times -5 is a positive 25. So that's probably the most common mistake that I see with these. Otherwise, most students are just fine with these. All right, so number 4, we're going to use the distance formula to find the distance between 210 and -5, 4. Okay, so I'll plug in my x values, I'll plug in my y values. It doesn't matter which point you start with, x1 and y1, x2, x2, x1. It doesn't matter which one you plug in. From there I can solve. I'm going to solve everything inside of the parenthesis. I'm not going to distribute the squared. I don't see that too often, but one of you might end up surprising me. And then I will square those, and then I'll add them together, and then I'll just plug into Desmos the square root of 85, and I get approximately 9.22 units apart. Okay. Next one, find the length of the diagonal of a rectangle if the rectangle has a length of 10 inches and a width of 5 inches. Okay, so we have rectangle, if you need like a visual of what's going on here. So we have a rectangle, beautifully drawn, we want to find the length of the diagonal. If the length is 10 inches and the width is 5 inches. Okay, so basically I have that right triangle. This is my right triangle, and I'm trying to find the hypotenuse. Okay, so let's get rid of that. Okay, so we have 10 squared plus 5 squared equals c squared, the length of my hypotenuse. So I'll square all of that, add them together, and then take the square root of both sides, and I have c to equaling approximately 11.18 inches. All right. And then just the last part, we've seen both slope and distance formula from several different perspectives. Distance formula today, slope formula in the last little lesson. In general, given the points x1, y1, and x2, y2 on a graph, you can draw a right triangle, label the sides as shown in the graph here. Okay, so we have A, B, and then D is our hypotenuse, essentially. Doing so allows us to write expressions for the distance, D, between the points and the slope, M, of the line that passes through those points. There's multiple expressions that can be written for distance and for slope. So, write an expression for the distance and expression using the slope, for the slope using A and B from the graph. So, in order to find distance, I can just use something similar to the Pythagorean theorem. I can have my a squared plus my b squared equaling d squared. But if I want to solve for d, I'm going to take the square root of both sides. So it's really going to be the square root of a squared plus b squared. Notice, where is it? Super similar to the distance formula. Okay, hopefully that wasn't too shocking. And then my slope, remember slope is rise over run. So how far up did you go and how far over did you go? So rise over run will give me, in terms of A and B from the graph, it's going to be A over B. Just rise over run. Which is essentially what you're already doing when you have, in the last lesson, when we had just a line through the graph and I asked you to find the slope, you were essentially just counting the rise over the run like you were doing here. Nothing new happened. And then for part B, write an expression for the distance and an expression for the slope using the coordinates shown in the graph. Okay, distance formula is just right here. I'm not going to read it out to you. There's a distance formula and there is the slope formula. If you needed a little bit of help making those connections, this picture is very helpful. This was our A, this was our B. So I just plugged this in for A and I plugged, and this in for B. That's all I really did there. Okay, and is that all I have? Yes, that's all I have for today. No, did I say 7? Let me double check. No, I didn't say 7. The answer key has 7. If you want to do 7 on your own, go for it. Otherwise, go ahead and do the homework problems.